Okay, Java IO stream. So these are the set of topics that we are going to cover. So we are going to learn what an IO stream is, and we'll take a look at the types of streams, and we are going to take a look at stream IO classes that are provided by JDK, and then we are going to learn the concept of chaining, and then we're going to actually look into various sets of streams: byte streams, character streams, buffer streams, standard IO streams. Yeah, so when we use system.out, that is actually representing output stream. Okay, so those are standard output, input and output streams. And I will talk about data streams and object streams. And finally, we are going to see how file class could be actually used for accessing and manipulation of files and directories. Okay, so what is an IO stream? So IO stream is a sequence of data. Okay, by the way, we are going to use the term stream as well. So IO stream and stream, we are going to use these two terms interchangeably. So an IO stream is associated with different kinds of sources and destination. So typically, when we get something, we typically get something from the keyboard or from a file, right? So these are all different types of stream sources. Okay, so it could be this file, or it could be devices, or it could be network socket, or it could be memory, right? And those things also could be destinations. We could actually write things to the file, to a file, or to a memory, or to a network socket, and things like that. So IO stream is associated with a source and destination, and there are different kinds of sources and destinations. Okay, so streams also support different kinds of data. So it could be bytes, it could be characters, it could be data types, it could be objects. Okay, so we are going to actually see all these different types of data being used. And some streams simply pass the data, while other streams actually perform some manipulation and transformation. Okay, so we're going to see examples of this as well. Now, regardless of how they work internally, meaning regardless of regardless of the different type of sources and destination, different types of streams, programming model is pretty straightforward and consistent. Okay, so JDK provides a very consistent programming model regardless of what streams you're going to deal with in your application. Okay, so we'll actually take a look at that. All right, so this picture shows input stream from a source. So we have a program here, right? And this program will actually receive something from a data source. Again, this data source could be a file or from the keyboard. And the data is coming from this data source to a program in a form of a stream. So this stream is going to be called input stream. Okay. Okay. So input stream is data coming from a data source to the program. Output stream is the other direction. So output stream is from the program. You actually writing things out to some data destination. Okay, so that is output stream. Okay, again, this data stream, this data destination could be a file, or it could be a network, it could be a memory, and things like that. So let's talk about types of streams. So there are three different categories that you can use. Three different categories of streams that you can use. Okay. First, it could be character stream or byte stream. Okay. So it represents either character or byte as a content, as the type of the data that is being transported. Or it could be based on direction, of course. So it could be input stream or it could be output stream. Okay, so that is distinction based on direction. And then the third is something I actually mentioned already. So whether data on a stream is manipulated or not. Okay, if it is being manipulated or transformed, the same thing. It is called a filter stream. While it is not being manipulated and transformed, then it is a node stream. Okay, so you can use these three different categories to distinguish the types of streams. So let's talk about character and byte stream. So byte stream is for sending binary data. So it is, each data item is a byte. Okay. On the other hand, character streams are for Unicode characters. So character stream actually understands, the characters based on the international characters. Okay. So ByteStream, the root classes for ByteStream is InputStream class and OutputStream class, and both classes are in fact abstract classes. Okay, for character streams that are passing the Unicode characters as data type, the root classes are reader class and writer class. And again, these two classes are abstract classes. Okay, so that's the distinction between character versus byte. Now let's talk about based on the direction. So input stream and output stream, obviously. Okay, so input or source stream. So those are the same thing. Is basically for reading data from these streams. Okay, so root classes for all input streams are input stream class and the reader class. Okay. And output, we call sometimes sink or destination streams. You're actually writing something to these streams. And the root classes of all output streams are output stream class and writer class. Okay. Now, node and filter streams. As I said before, filter streams are the ones. So let's talk about the node streams first, and then we'll talk about filter streams. So node streams is basically contains basic functionality of reading or writing from a specific data source. Okay, and the types of node streams include files, memory, and pipes. Okay, it's basically reading things or writing things. Okay, to file, memory, and pipes. Now, filter streams, sometimes it's called the processing stream because it's actually do some manipulation. It does alter or manage or do something with the data. Okay, and it is layered onto the node streams, meaning it is on the top of. The filter streams are always on the top of node streams. Okay, so we use the term like onto or on the top of, or we use the term like a wrap node streams. Okay, so you'll see examples of filter streams later on. So filter stream cannot actually exist by itself. Okay, all right, so adding layers to a node stream is called the stream chaining. Okay, so when you happen to have some input and output stream from node streams, you're going to apply or wrap or lay on the top of filter streams, and that's called the stream chaining. Okay, so we'll see an example in a second. Okay, so let's see the stream class hierarchy. So this picture actually shows the streams. So you can see we have object here, which is the root of all classes, and then we have an input stream, then we have an output stream here, and then we have a reader and writer. So this reader and writer, these are representing characters, Unicode characters, and input stream and output stream represent bytes. Okay, and on the input stream you have byte array input stream and file input stream and the filter input stream and things like that. So here you have a node stream as well as filter stream. So you can see file input stream is a node stream. Filter input stream, on the other hand, is a filter stream. Okay, all right. And then we have also on the filter input stream, you have a buffered input stream and data input stream and pushback input stream. These are all filter streams. Okay, all right, and then we have a corresponding things for reader and writer. Okay, so let's take a look at these streams. So let's first take a look at what a stream chaining look like. So stream chaining on input operation. So you can do stream chaining on both reader and input stream classes. So here we have a file reader, the reader class. Okay, and file reader could be created from a source file. So you got the file reader object. Now you are going to wrap or lay filter stream. So in this case, buffered reader is a filter stream, which is laid on the top of file stream. So now we are actually basically chaining these two streams. Okay, so we use the term lay or wrap or chain. Okay, so now buffer reader is chained with a file reader. So what happens is that file reader read the data, then it's going to pass to the buffer stream, buffer reader stream, buffer reader, not the buffer stream. Okay, then we have the buffer reader object, which is in fact the chained stream of these two. Okay, and you can actually combine these two statements in a single statement like this. You basically create the file reader object, and then from it you're going to create the buffer reader object. So here these two lines is combined into a single line, so they are the same thing. So this is an example of stream chaining for input operation. Same thing for the stream chaining for output operation. So here we have file writer object, and then you are going to chain buffered writer with the file writer. So when we get the buffered writer object, that is a chain version of the the writer object. Okay, and again, these two could be written in a single line. So here we create the file writer object and then directly pass it to the buffered writer object. Okay, so these are the examples of stream chaining. So filter streams. So the filter streams are the ones that perform this wrapping. So we see examples of buffered writer or buffered reader, right? So if you see buffered so this is stream case, but we also have a corresponding case for the writer, right? So we have input data stream and line number input stream and buffered input stream. So we have a buffered input reader, as we have seen in the previous slide, pushback input stream, and then for the output stream, we have these filter streams. So these filter streams are actually being used only with node streams, and they are always laid on the top of node streams. Okay. Okay, so let's take a look at these streams in a bit more detail. Okay, so let's start with a byte stream. So byte stream deals with the byte streams, meaning it deals with 8-bit byte. Okay, so as we learned before, all byte streams classes are descended from the input stream and output stream abstract classes. So examples of byte stream classes are file input stream and file output stream. So these two classes are used for reading data from a file on byte by byte basis, or write byte by byte basis. Okay, so that is byte stream. So let's see an example here. So in this case, we have created the file input stream from this file, and then we also created file output stream object from out again the text file. So basically what we want to do is we want to read. So when you are calling this line here, so when you call in.read, it's going to read a single byte from this stream. Okay, so as long as it's not -1, meaning end of the file, we are going to write that byte into this output stream. Okay, so it's very simple code. And at the end, we want to close these streams. Okay, so we call close method. So here, we are dealing with reading and writing from a file to a file per byte basis, single byte basis. Okay, so this is a single byte stream. So it's basically reading a single byte from input stream, and then it's going to write that byte into output stream. Okay, so 8-bit byte is being dealt with here. Okay, so let's do our first exercise. So exercise 1. So let's open the lab documentation. So Java SE and IO streams and index file. So here we are going to actually play around with the excuse me. We are going to play around with the byte stream first. Okay. So you can just open the project. So file input output stream, and so this is the code that we have seen. And this file is already provided as part of the NetBeans project. Okay, so let's actually run this application. So it's actually file input and output stream. So let's open that project. So I'm gonna just close all these guys. and open from IOStream samples bins. Here I'm going to open all this. And file input and output stream. So this is the one. So we are going to run it. So it's basically read it and write it, and it also actually a computer checksum. Okay, so if you take a look at the code, so that is a code that we have seen. Wait a minute, is this the right one? Yeah. Oh, we don't actually read the file, not filter. Actually, I was actually looking at the wrong one. File input and output stream. Yeah, this one. Okay. So run it. So yeah, so these are, basically these are the characters that are read from the file. So if you take a look at the code, it's reading a file called Farrago.txt file and then writing to out again the text file. So if you take a look at the files view, and you're going to see that file. Okay, so this is Farrago text, right? And this is out again. So I'm gonna just delete this out file. Okay, and then we're gonna run it again, and then we should actually have our file being created again. Okay, so let's run this application again. And then if you take a look at that, then you can see it's actually being created. Okay, so code-wise, it's pretty simple. So you just read it, and then we just write that out to the system console. That's why you're actually seeing all these characters, all these characters project. Yeah, all these characters here. So you can see that is a byte, okay? And then we are actually writing to the output stream. So this file output stream is represented by out variable, and we are actually writing to it, okay? And at the end we close it, okay? Let's see, and yeah, so yeah, I'm gonna give you just like 2 or 3 minutes to run this application, and then we're gonna move on, okay? So just open the project and see what. Now we're going to talk about the character stream. Okay. So character streams are like byte streams, but they contain 16-bit Unicode characters rather than 8-bit bytes. Okay. And they are implemented by reader and writer classes and their subclasses. Internally, it's going to use input stream and output streams. So readers and writers support essentially the same operations as input and output streams, except that where byte stream methods operate on byte and byte arrays, character stream methods operate on characters and character array or strings. Okay. So this is the code, and as you can see, the code is exactly the same. Okay. So here, instead of using file input stream, we are going to use file reader. The stream class, file reader class, and instead of file output stream, we are using file writer class. Okay, and everything else is the same here. So here, basically we are actually reading character by character. Okay, yeah. So in terms of the operations that we dealt with in our file, it's actually working exactly the same. Okay. So character streams are often wrappers for byte streams, and character stream uses a byte stream to perform the physical I/O, while character streams handles translation between characters and bytes. So basically, because it's dealing with characters, it will actually perform the translation between bytes and this Unicode. So in our example, if the text file that I provide, that's actually English, okay? But if you happen to have some file that contains multi-character file like a Korean or Japanese or Chinese, then the output behavior might be actually different. In our case, since we are dealing with English ASCII characters, the result is going to be pretty much the same. Okay. All right, so why you want to use a character stream over a byte stream? So the primary advantage of using character stream is that, if you are writing an application that are supposed to be internationalized, okay, I mean, that's always the case, right? Then, the character encoding and decodings are handled by these character streams, okay? So you don't have to actually do the encoding and decoding yourself, okay? So and also, if you're using ByteStream, you have to perform this character encoding and decoding yourself, and sometimes your implementation is not going to be that much efficient. In fact, character stream implementations from JDK, they are highly optimized. Okay, so it's strongly recommended that you use the provided character stream classes that are coming from with the JDK. Okay, all right, so that is the point. So let's take a look at the exercise 2. So exercise 2 is exactly the same file, and then we are basically, doing the same thing. Okay? Yeah. So yeah, this is probably that much of a big deal. So why don't you actually move ahead? Okay. Okay, buffered stream. So why use buffered stream? So in the examples that we have seen so far, we were using bytestream class and character stream class, and it was reading or writing a byte or character one at a time, and that is very, very inefficient. Especially, performing I/O operations is very, very expensive. Okay, so you want to reduce I/O operations as much as possible in order to have a good performance. Okay, so what we can do is that we want to actually collect the data before we write, we perform an I/O operation. Okay, so unbuffered I/O means each read and write request is handled directly by underlying OS, and again, that's very, very expensive in terms of performance. Okay, so to reduce this kind of I/O overhead, you want to use buffered I/O streams. So this buffered I/O streams is basically, in a sense, is actually doing some manipulation, meaning it captures the data before it writes, or it captures the data before yeah. So basically, buffered input streams read data from the memory as a bigger chunk than what you requested. So instead of reading a single byte, it will read, big chunk of it, assuming you are going to actually ask for it later, okay? And instead of writing a single byte or a single character to output stream one at a time, buffered output stream will actually collect the data into a buffer, and then it will actually do write as a single big chunk. Okay, so that is what the buffer streams are all about. Okay, so basically, by using buffer stream, by actually chaining or wrapping or laying buffer stream on the top of the node stream, you are going to actually have a better performance. So this is what you do. So again, this is an example we have seen before. So we created a file reader object, and then we chain the buffered reader with it. Okay, so that we now have input stream that is gonna be providing the buffered input streaming, and the output stream here is going to do writing in a buffered fashion. Okay, so providing better performance. Okay, so buffered input stream and buffered output stream, that is for by streams, and buffered reader and buffered writer for characters. Flushing buffered stream. So sometimes you want to flush the data, at a particular point. You don't want the buffer stream. So buffer stream will actually determine itself when is the right time to flush the data to the output stream. Okay, but sometimes you want to have a control in terms of when to write. Okay, so that is actually for flushing. So it often makes sense to write out a buffer at critical point without waiting for it to fill. So this is called flushing the buffer. Okay. Now, some buffered output streams support auto flush, specify the optional constructor argument. So when auto flush is enabled, certain key events will cause the buffer to be flushed. So example of that is print-to-write object will flush the buffer on every invocation of println or format, the method. Okay, so the print-to-writer will actually get the indication that the invocation of println and format will actually trigger the flush the data in the buffer to the output device. And to flush a stream manually, invoke a flush method. You can actually call flush method on an output stream to actually force the flush. Okay, so you can also perform line-oriented I/O. So here, the character I/O usually occurs in bigger units than single characters. So I mean, line is a good, let's say, boundary for performing I/O operations. Okay, so line terminator for Windows is /L and /N, and for macOS and the Linux is going to be /N character. Okay, so we have buffered the reader here, and then we can call the read line method to read to read a line. Basically we want to read all the characters up to /N or /Ln. Okay, so that is line-oriented I/O. Okay. Exercise 3, so let's take a look at the code. So again, it's not that much of a big deal. So here, basically we have, so we actually receive arguments, and the first argument, if it doesn't provide arguments, then we can actually set it where's text, where's out text, and the third is 3. So here we are going to create simple encryption class. And then we are going to basically encrypt. What you want to do is we want to encrypt this one, and the result is going to be sent to words out that text file. And then third is actually number of things you want to shift as part of this simple encryption. So if you take a look at the simple encryption code, all you do is basically here we created buffered reader object, and then we read line by line, and then we we read a line, and then we write. Okay, and then we keep this is reading the first line, and then we actually write to the buffer writer, and then we are going to read again, and this is in the while loop. Okay, and so this is view file contents. Okay, and so basically this is the file, and we want to so basically it's actually doing some kind of shifting as a scheme of encryption. Okay, so basically we shift, the size of the shift is the number 3, and we are just shifting it, and then we write it. Okay, so output is going to be something like so this is input file. So we're going to read line by line. Okay, and then we are going to perform encryption, and then each encrypted will be written to output file. Okay. Okay. So right now it's 11:40. So I will give you guys 5 minutes for this, and let's have 10 minutes break. So we'll be back the 55 after the hour. Okay, so right now in Boston is 11:40. I'll give you 5 minutes for the exercise 2 and 3, and then we'll have 10 minutes break. So we'll be back in 15 minutes. Next topic is data streams. So data streams support binary I/O or primitive data type values like a Boolean, character, byte, short, int, long, and float, as well as string values. So these streams are supposed to be these streams actually implementing data input interface and data output interface, and we'll see what kind of methods that these interfaces have. So data input and data output has the double or write double, read int and write int, and read and write UTF and things like that. Okay, so again, data output stream and data input, data writer, those are basically, there is no data writer. It's actually all a stream because we're actually dealing with these primitive values. Okay. So you are actually wrapping or chaining. So this is the case that we have chained three output stream object, volume output stream, and then buffered output stream, and then data output stream. Okay, so once you got the data output stream, then you should be able to write double object, and you should be able to write int object, and you should be able to write like a UTF object and things like that. Okay. Input stream, the same thing. So you're going to chain data input stream to, in this case, buffered input stream and file input stream. Okay, so of course you can actually have data input stream directly to file input stream. In that case, you don't get the buffering, but that's certainly possible. So here we are going to read double value from the input stream, and reading int value from the input stream, and reading UTF from the input stream. Okay, so that is the data stream, and I'm going to continue some presentation, and I'll give you guys some time to play around. Is a little bit bigger chunk. Now moving forward, object stream. So object streams are for writing and reading objects. Okay, and we haven't actually learned the concept of serializable yet. Not every object is in fact serializable. So only objects that are serializable type can be serialized, meaning they can be created as a file, or for example, so basically so that you can actually save an object into a file. You can read the object from a file. Okay, so the object has to be serializable type. Okay, so by the way, so serializable is interface. Okay. Okay, so object stream classes are object input stream and object output stream. So it implement object input and object output. Okay, they are in fact sub-interfaces of data input and data output. So they are, in a sense, the specialized type. Okay. Now, the write object or read objects are simple to use, but underneath what goes on is very complex because, as you probably figured, object in Java program is not very simple. It could actually have another object. It could have a properties and methods, and the properties could be another object type, right? And then that object could actually contain another object as its own property. So it goes on, and you could have a multiple levels of object references. So when you save that object, all those information has to be saved into the serialized version of the file, for example. So underneath it actually goes through what is called the object graph. That object graph has to be constructed and saved. Okay. So for simple object like a calendar, which just contains a primitive values, is not that much of a big deal. But many of the application level class contains multi-level object references. So those things need to be constructed and saved. And later on, when you are reading that object using read object method, then all those things need to be constructed. Okay. But again, you don't really have to worry about it because write object and read object, those things are all those methods all handle things for you. Okay, so write object method will traverse the entire web of object references and write all objects into the web. I mean here web, I'm talking about into the object graph onto the stream. So you just basically call write object method and then pass the object, and then object graph will be traversed and everything will be saved for you. So very simple to use, but underneath it goes through quite a bit of operations. So this is basically what happens when let's say we have object A which has object B as a property and object C as a property, and object B itself has a D and E as its own properties, right? And let's say these guys are all different, classes. And then what has to happen is when you call the write object passing this object A, and then stream has to pass all this information. Okay, so that later on, another application is going to call read object. Okay, from the stream, it should be able to reconstruct the exact object like this. Okay, so all those references information have to be serialized as well. Okay, so IO of multiple refer to object. Yeah, so this is basically, invoking write object writes not just A, but all the objects necessary to reconstitute an A. So what we're talking about, all this B, C, D, E, all those things need to be also saved into the stream. Okay, so that's basically what he's talking about. So that when A is read back by read object, the other 4 objects are read back as well, and all the original object references are preserved. Okay. All right, so exercise 5. So let's actually do exercise 4 and 5. So let's take a look at the exercise 4. So here, this is a data stream. So here we are going to create a data stream from file output stream. So we are not using buffer stream. So this is the chain of 2 streams. Okay. So we have a data output stream out. And then we have a bunch of primitive values. And then we are going to write double value, character value, int value, characters, and character, and things like that. Okay, so these methods are all from the data output interface, okay, which is implemented by data output stream. Okay, this is reading again. So we are going to read you basically read invoice, the file. And then we are going to wrap it with the data input stream so that we can call this method, read double, read character, and things like that. Okay. All right. So yeah. So this is actually invoice. Yeah, we are basically writing this data to file called invoice. Okay. And then we are reading it, and then we are reading it, and then we are reading those data back. Okay. All right. So that is data. Okay, so here, data input and data output. So, yeah. So, just do for that one. As long as you get the concept, that's good enough. So just do for that one, and let's move on to object stream. So here we are going to have card3. This is our custom class. So if you take a look at the custom class, this is card3, and you can see it's serializable. Okay, so card3 has its own this one doesn't really have any other properties. It's just a collection of ints, right? Okay, so when we actually save, so we create a card object, and then we have created file output stream, and then from it we created object output stream. Okay, and then we are basically saving card. Okay, and basically what we do is we are going to save that the object into card out. Okay, so you should be able to actually see card.out file has been created, and from the card out we are going to read it again. Okay, and we should be able to construct the card3, and then we should be able to do anything we want with that object. That should actually reflect exactly the one that I have created here. Okay, so you might want to actually change the name of the file, to make sure that new file has been created and new file is being read, and and you could in fact write another application that just separate this out. You could actually have this one to just write it, and another application to read this one as the object input stream, and see whether you can actually create the card, and whether you can actually invoke a method, okay, of the card object. Okay, so that is the exercise. All right, so I'm going to give you guys 10 minutes for doing the exercise 4 and 5. Okay, so next is a pipe streams, and pipe streams are sort of simulating the pipe command in a pipe operator in macOS and Unix environment. Okay, so a pipe input stream should be connected to a pipe output stream, and the pipe input stream then provides whatever data bytes written to the pipe output stream. Okay, so in Unix, you can actually have two different commands, the connected through a pipe, right? So whatever output from the first command should be actually provided as an input to the next, right? So this is exactly what it does. The pipe input stream and output stream exactly that does that. So typically, data is read from the pipe input stream object by one thread, and data is written to the corresponding pipe output stream by another thread. Okay. Okay, so I'm gonna actually move ahead. And the standard streams. So these are the standard streams that we have worked on before. So typically we use system.out standard output stream, right? So if you again go to system.out, so let me actually show you one more time. So let's go to any yeah. So here you go. So let's take a look at the documentation again. So system has a public property called the out. And you can see out is basically the output device, output stream. Okay. Okay. It's taking its time. Yeah, my network is okay. Okay, here you go. So the system has out, which is a print stream. Okay. And in is input stream, and error is a print stream. So basically, if you go to print stream, these are class hierarchy structure. So we have print stream is immediate parent is filter output stream, and then its immediate the parent is output stream, and then is from object. Okay. So because then so the println statement is from here. So printf, println, these are from this print stream class. Okay. Yeah. Okay, so these objects are defined automatically and does not need to be opened. Yeah, so standard devices, standard streams are automatically opened, so you don't really have to open it yourself. Okay, and system.out and system.error are defined as print stream object. Okay. Okay, so let's talk about closing streams. So closing streams is important. Otherwise, you might in fact have resource leak. I mean, operating system's supposed to close these resources, but it's better for you to close these streams because streams is taking some resources. So those resources need to be closed. Okay, so good programming practice always is to close these streams in your finally block so that these resources do not get leaked. Okay. All right, so file class. So file class is not a stream class, but file object actually is used for manipulation of files and directory. Okay, so let's take a look at yeah, so you can create the file object. This is a constructor. You basically provide a name of the file or directory. Okay, I believe, yeah, this file should actually handle the directory as well. Okay, so exercise 7 is the file handling. Okay, let's see. Let's take a look at the yeah, pipe stream. So yeah, this is actually rather a little bit complex. So I'm gonna actually just ask you to run the application and and see the result. Okay, so it involves the threading and all those things. So I'm gonna actually let's not actually spend time on this one for now. And so it's not probably that critical for you to understand this particular example in detail. So just run the application and basically, it's just being read and actually then it's actually getting into another. It's being read in one thread and it's actually being actually written in one thread, and then that another thread is actually reading it using pipe input stream. So that's the code, but since actually it's involved some complexity, I decided to actually kind of skip this one. and move forward. And exercise 7 is file and directory handling. So here we are, creating a file object, and we can call the getName method, and we can check whether file exists or not. We can then read whether we can read or not. Yeah, so that's can read, and then we can find the length of the file. We can see whether that is the writable. So these are checking the permissions. Okay, and then then you can also, yeah, so dummy name. So that's the argument. So it's basically checking all those things. And 7.2 is directory handling. Okay, so this is a file, and you can actually check. Yeah, so the from the fn command, you can actually check whether that is a file or directory. Okay, so that is in fact is file method to let you know whether that is a file or directory. And then you can actually get the list. If it is a directory, you can call the list method of it. Okay, and then you can also delete. Okay. And random file access. So here, right? Yeah, so we have a random access file, and then you can actually call it like a sig. Yeah, so yeah, basically. Okay, so I'm going to give you just maybe I'll give you 5 minutes to just do exercise 6 and 7. Yeah, for 6, just try to run it and how things work out. And for 7, take a look at the code a bit. Okay. Okay, so let me stop